Hello and welcome back to my channel. Today in this video we are going to discuss the last 5 questions from May-June 2021 Cambridge AS and A-Level Mathematics. It is paper 1, that is pure mathematics 1, and the component is 970911. So let's start with the question number 7, A part. It is prove the identity 1 minus 2 sine square theta over 1 minus sine square theta is equivalent to 1 minus tan square theta. And in AS level we have two identities which we are going to use. One is tan theta as sine theta over cos theta. Another is sine square theta plus cos square theta is equivalent to 1. They are equivalent. Equivalent means like we can write in place of this as the right hand side. So the left hand side here become, if we separate it or we use the identity, second identity, sine square theta plus cos square theta is equivalent to 1, we can get cos square theta as 1 minus sine square theta. So it become 1 minus, denominator become cos square theta. And in numerator we have 2 times sine square theta, that's negative 2, so it means sine square theta minus sine square theta. We actually had to focus on splitting the things so that we can get everything in the sine and cos alone without any coefficient like 1, 2 or something, 2, 3 or something. It should be 1, and hence we got the numerator as cos square theta minus sine square theta upon cos square theta, and then you can separate it. We can write it as cos square theta upon cos square theta minus sine square theta upon cos square theta. Now we will use the identity. This is 1, so 1 minus sine theta over cos theta is tan theta, so sine square theta upon cos square theta become tan square theta, and that's the right hand side, hence proof. And here is the B part. Hence solve the equation 1 minus 2 sine square theta upon 1 minus sine square theta is same as 2 times tan power 4 theta between 0 to 180. So from the A part we have seen that this is equivalent to 1 minus tan square theta, so we will write this equation as 1 minus tan square theta equals 2 tan power 4 theta. Now we can see it's a biquadratic or quartic equation, so we can take tan square theta as, let's say, x. So we will get this, and we will transfer this to the right hand side, and we will get this as 0 equals to 2x square, because we have taken this as tan square theta as x, so tan power 4 theta become x square, and then it is plus x and minus 1. And now we will factorize it. We can see it is 2 into 1 2, so it become, we can write it as 2x square plus 2x minus x minus 1 equals 0. Or we can use our calculator also to factorize it. That's not a thing how we factorize. 2x common, so it become x plus 1 minus 1 common, x plus 1 equals 0. Or then we got x plus 1 equals 0, or 2x minus 1 equals 0, and means we got two values of x, one as minus 1, another as 1 over 2. And since tan square theta is x, so tan square theta would be minus 1, and it is not possible because square number cannot be negative in the real situation. And then the next one is tan square theta equals 1 over 2, and from here we can get tan theta as plus minus 1 over root 2. And then we've got two values of theta. One value we will get tan theta is 1 by root 2, that is tan inverse theta become tan inverse of 1 over root 2. Another value we will get it from tangent inverse minus 1 over root 2, and then we will get these values from calculator. Tan inverse 1 over root 2. So this value from the calculator we are getting 35.26, so we can write 35.3 degree, and this value is coming minus 35.26, so it is 35.3 degree. And since we require our answer between 0 and 180 degrees, so this is acceptable, but this is not acceptable because it's in the negative. And if we have tan, then we can talk about the other angle. So other angle we will get it by 180 plus, so theta would be 180 plus minus 35.3 degree, and this value we will get this value as 180 plus this is 144.7, so 144.73, that is 7 degree. So the answers, the solutions of this is going to be 35.3 degree and 144.7 degree. No other solutions are possible. Now here is the 8th question. The diagram shows a symmetrical metal plate. It's symmetrical. The metal plate, the plate is made by removing two identical pieces from a circular disc with center C. The boundary of the plate consists of two arcs PS and QR of the original circle and two semicircles with PQ and RS as diameter. So PQ is an arc and PQ, this length is the diameter, RS is the diameter. The radius of the circle with center C is 4 centimeter. PQ is same as RS as 4 centimeter also. First part is show that angle PCS equals 2 by 3 pi radian. So let me join the points which are required. So if we join these all according to the question, since CS will also be a radius of the bigger circle, so it is 4, so it is also 4, and it is given that PQ and RS both are 4, so it means this become the triangle CSR become an equilateral triangle. So all the angles, this angle, all the angles in the radian pi by 3, they all are same, that are pi by 3, and hence we can get angle PCS just by linear pair 180 minus sorry, not 180, it's not in the degree, pi minus pi by 3, and that is 3 pi minus pi over 3, and it is 2 by 3 pi radian, and that's the angle PCS. So we got this angle as P2 by 3 pi. Here's the B part. Find the exact perimeter of the plate. So let me bring the diagram here. Yeah. So from here we can see we require the perimeter. Perimeter means these two arcs and these two semicircles. So from the previous part we have seen that this angle, if we join this and we have this angle as 2 by 3 pi. So it would also be same, these two, it's a symmetric, so PS arc is going to be same as the arc QR, so it is going to be perimeter P would be same as the PS, I will write like this, arc plus SR, this is also an arc, then RQ, this is also an arc, and then the last one QP. So we have the central angle we can directly find by the formula r theta, arc length is r theta, and r is 4, we know the radius is 4, so it is 4 into 2 by 3 pi plus SR. SR means this is a semicircle, and radius, the total, the diameter was 4 centimeter, so the radius would be of course 2, so the semicircle perimeter of diameter would be 2 pi r by 2, that is pi r only, and that is going to be 2 into r, 2 into pi, plus rq. Rq is same as ps, so it is also 8 by 3 pi, and the last qp is same as rs, that is going to be 2 pi. We could have added this because it forms a complete circle, so it would be 2 pi r, that is 2 into 2 pi, and that is going to be same as this, so that's fine. And now we have 8 by 3, 8 by 3, that is 2 8 by 3, so it becomes 16 by 3 pi plus 2 pi plus 2 pi is 4 pi. Now we will add them. 12, 6, 3 4 are 12, so 16 plus 12 is 28 over 3 pi, and that's the exact perimeter, because since they have asked for the exact perimeter, so we don't have to solve this, and that's the perimeter of perimeter of this. And if this is given as 4 centimeters, so it would be this centimeter. Let us check whether it is given as a centimeter or what. Yeah, it is given as centimeter, we can see. So the perimeter is 28 by 3 pi centimeter. And here's the C part. Show that the area of the plate is 20 over 3 pi plus 8 root 3 centimeter square. So I will bring the diagram. Here we can see that we require this area. Area of the plate means this area, and from here we can see properly that how it is formed from a circle. This is a bigger circle, and then this is a segment, and this is a semicircle. If we remove this part, then we get this plate. So similarly here we remove this to similar part as well, so we get this area. And how do we do that? Let's divide into, join these points, related points, and we figure it out how to do. Yeah, here we can see if we join these all, since it is symmetric, so it will pass through this, and we have this angle from the first part itself. We have seen it is pi by 3 because isosceles equilateral triangle, sorry, and it is an equilateral triangle, and the radius of the smaller circle, this circle, is 2 because the total length was 4, and hence we can find, and these two are same because they are radius and of length 4 centimeter. And first of all we will find the area of segment, and then we will find the area of circle, this semicircle, and we will double it because we have the same area upward as well, and then we will subtract this two area, combined area, from the circle, the total area of the bigger circle. So first of all, for the area of segment, we will calculate area of the sector. Area of sector is half r square. R square means 4 square, 16, and theta is pi by 3. So it becomes 8 pi by 3. And then area of segment means area of, if we need to subtract the area of triangle, so we will find the area of triangle by sine sine rule. Area of triangle is going to be half AB sine theta. So it is going to be A into B, that is 4 into 4, sine theta, that is sine pi by 3, and sine pi by 3 is root 3 by 2, or we can use the calculator to find out this value, and then 2 got cancelled. This is only 1 4 left. So area of segment is 4 root 3. Area of sector minus area of triangle, that is 8 pi by 3 minus 4 root 3. That's the area of this segment. So the total area, or we can say the total segment, area of segment means we have to subtract this as well. So it becomes twice of it. So area of both segments are going to be 16 by 3 pi minus 8 root 3. This is the area of segment, and then we'll find the area of semicircle, and we can see there are two semicircles, so it forms a circle. So area of smaller circle, area of smaller circle is pi r square, that is pi into 2 square, it is 4 pi. And area of bigger circle is again pi r square, but here the radius become 4, so it is 16, 4 4 the 16 pi, and hence the required area is bigger circle 16 pi minus sum of these two areas, area of segment and the circle, smaller circle. So it is 16 by 3 pi minus 8 root 3 plus 4 pi. So we will simplify it. It is 16 pi minus, this is going to be 16 over 3 pi minus 8 over 8 sorry, it's 4 pi, so 4 3s are 12, so it is 28 over 3 pi and minus plus 8 root 3, and we will simplify 16 3s are 48 minus 28 is 20, so it is 20 over 3 pi plus 8 root 3 centimeter square, and hence that is what we had to prove. So it is 20 by 3 pi 8 root 3, that is centimeter square, and that's the required area. I hope it is clear. Let's do the next question. And here's the next question, 9th question. The functions f and g are defined as follows: fx as x minus 2 whole square minus 4 for x greater than or equals to 2, and gx ax plus 2 for all real number, where a is a constant. First part is to state the range of f. So from here, this function, since it is given in this form, we can find the minimum value. And why it is minimum? Because x square coefficient would be positive here. So we can see the minimum value of this would be 2 comma minus 4, and 2 is in the domain, so this will give us the range, and hence the range of f is fx greater than or equals to minus 4. Since it is a minimum point, so it has to be greater than or equals to minus. Question: the equation of a circle is x square plus y square minus 4x plus 6y minus 77 equals 0. Find the x coordinates of the points A and B where the circle intersects the x-axis. So if you have a circle, and whenever we find the intersection with the x-axis, this means y should be 0, because on x-axis y is 0. So we got this equation of circle as x square plus 0 minus 4x plus 0 minus 77 equals 0. So it is only x square minus 4x minus 77 equals 0, and that's going to be factorized. X square minus 11x plus 7x minus 77, because if we subtract we'll get minus 4, if we multiply we'll get minus 77. So that's the correct factorization. X common, x minus 11 plus 7 common, x minus 11 equals 0, or we can write it as x minus 11 into x plus 7 whole square equals 0, means x values we got it as minus 7 and 11. So we can mark them as A and B. So we can see that A would be x coordinates of A, we can write x coordinates of A would be minus 7, and x coordinates of B would be 11. So they are the intersection point of the circle with the x-axis. B part is find the point of intersection of the tangents to the circle at A and B. So I will sketch the scenario then, so that we can see what we are finding. So it is done by the software. Now we can see this is A, we have seen it is minus 7, B it is 11. So we have drawn the tangents, and it meets here. So that's the point we are finding, and find point of intersection of the tangent. So that is what we are going to find, 2, 27. So this is from the graph, but we will do it algebraically to that, so that we can get the answer. So for A and B, the tangents A and B, we are going to first of all write the equation of circle: x square plus y square minus 4x plus 6y minus 77 equals 0. So the how we solve it, we are going to solve for the gradient, and we actually will find the equation of this tangent, and then we'll solve the simultaneous equation, and we will get this value as 2, 27. So for that, we are going to find the gradient for this. So the circle, if we talk about the circle, if you have the circle here, so before that, if we can somehow find the center of the circle, then we can talk about the gradient of the tangent, because it would be of course 90 degrees. So we can find the gradient by just taking the negative reciprocal, or we can use the implicit differentiation here, so that we can get dy over dx, and dy over dx will give us the gradient. So I will find the center first of all, and for center we have to write this in x minus h whole square plus y minus k whole square equals r square format, and then with h and k, h comma k would be center and r would be the radius. So here we can write it by using the completing square method. It is x square minus 4x plus y square plus 6y equals 77. Now we will use these two to complete the square. X minus 4 by 2, that is 2 whole square, and I will write the same which we need to subtract here. I will add here, that is 77 plus 2 square, that is 4. And similarly here, y plus 6 by 2, 3 whole square, and then we'll subtract minus 3 square. Here it would be add, so it is going to be plus 9. And we got x minus 2 whole square plus y plus 3 whole square equals to 77 plus 4, 81 plus 9. 77 plus 4 plus 9 is going to be 90. 81 plus 9, yeah, 90. And from here we can talk about the circle, center of the circle. Center become 2 comma minus 3, so it is here. Now we can talk about the gradient of line AC, or let's take it as O. So gradient of OA first of all. Gradient of OA, if it is 2 comma minus 3, it is y2 minus y1. So minus 3 comma minus, or let's take this 0 minus 3, that is only 3, and minus 7 minus 2 minus 9. So this means gradient of tangent at A would be negative reciprocal. It is going to be 1 upon 3. So negative reciprocal means it is 3 only. Now we will find the gradient of OB. Again, y2 minus y1, 0 minus minus 3 is 3, and 11 minus 2 is 9, hence it is going to be only 1 by 3, means gradient of tangent at B is going to be negative reciprocal, that is minus 3. So we can find the equation of tangent. So we have equation of tangent at A is going to be y minus y1 equals x minus x1. So m times x minus x1, y minus y1, that is 0, so it is only this, y equals m times, that is 3, and x minus x1, so x minus minus plus, so x plus 7. It means it become y equals 3x plus 21. That's the equation of tangent at A. Similarly, equation of tangent at B, we'll get this as y equals because y minus y1, that is y minus 0, equals minus 3x minus 11. It means y equals minus 3x minus plus 33. And then for the intersection points, for intersection we have to equate them. It means 3x plus 21 equals minus 3x plus 33, and there, if we find the point of intersection, that is going to be C. So from here 3 and minus 3, this will come here, it is going to be 6x equals 33 minus 21, 3 minus 1 2, 3 minus 2 is 1, and from here x become 2, as we have seen, and that is the answer. And we can get y value from any of this equation. I'll put it here in the first one. 3 2s are 6 plus 21, and that is 27. So the coordinates of the intersection point of these two tangents are 2, 27, and that's what we have seen from the software as well. So that's the answer for it. I hope it is clear. Let's do the next question. And here's the 11th question, that is the last question of this paper. The equation of a curve is given as y equals 2 root 3x plus 4 minus x. Find the equation of the normal to the curve at the point this. Giving your answer in the form of y equals mx plus c. So for the equation of normal, we should have the equation of tangent and gradient of the normal. And gradient of the normal means we get the gradient of normal from gradient of tangent. So first of all, we'll calculate dy over dx at 4, 4. And before that, we will use dy over dx. So dy over dx is, from here, it is going to be simple chain rule, 2 times 1 by 2 3x plus 4 to the power 1 by 2 minus 1, that is minus 1 by 2, multiplied by the differentiation of this, that is 3, and minus x differentiation is 1. 2 got cancelled, and we got this thing as 3, and minus 1 by 2 means in the denominator it is going to be only square root of 3x plus 4 minus 1. So if we got dy over dx, so from here at dy over dx at 4 means x value is 4, so it is 3 over 3 4s are 12 plus 4 16 minus 1, so it is 3 upon 4 minus 1, and that is going to be minus 3 minus 4, that is minus 1 upon 4, and that's the gradient of the tangent. It means gradient of normal would be negative reciprocal, that is only 4, and hence the equation of normal would be y minus y1, that is y minus 4, equals gradient 4 times x minus x1, that is x minus again 4. So we need to write our answer in this form. So from here we get y equals 4x minus 16, and minus this side become plus 4, and altogether we got y equals 4x minus 12, and that's the equation of the normal to the curve where at the point 4, 4. Now the C part is determine the nature of the stationary point. So for the nature of stationary point, we have to decide what is dy over dx2, the second derivative's nature. If it is greater than 0, then the point is going to be minimum, and if it is less than 0, the point is going to be maximum. The point I mean to say, it is 5 by 3 and 13 over 3. So first of all, we'll copy what was dy over dx. Dy over dx, so it is 3 over root 3x plus 4 minus 1, or we can rewrite this thing as 3 and 3x plus 4 to the power minus 1 by 2 minus 1, and then we will do the double derivative, second derivative, that is d2y over dx2. It is minus 3 by 2 3x plus 4 to the power minus 1 by 2, and it is going to be minus 3 by 2, and into the differentiation of the bracket by chain rule, so it is going to be 3 minus 0 because constant is there. Altogether we got this thing as minus 9 by 2 and we can take it in the denominator. It is going to be 3x plus 4 to the power 3 by 2. So now we have these values. X value is 5 by 3. If we put it here, we are not going to get negative value any which way, so this will be less than 0 because it is minus. So this, since we can write this value is always going to be positive, so it is minus 4.5, and hence it is going to be negative. So we can say 5 by 3 and 13.3 is a point of maxima, or is maximum point. Maximum point. I hope it is clear. And here's the D part, that is the last part of this question paper. And the question, so find the exact area of the region bounded by the curve, the x-axis, and the line x equals 0 and x equals 4. So we know it is given by the integration, so area, I will write a equals integration from 0 to 4 y dx. That's the area between x equals 0 and x equals 4. And from the previous part we have seen the curve is 2 root 3x plus 4 minus x. So if we want to integrate this, it means this is simply like 0 to 4 2 root 3x plus 4 minus x. So we are going to integrate them separately, 0 to 4. So the integration of this, since it 1 by root means 1 by 2, so it becomes 2 3x plus 4 to the power 3 by 2, 1 by 2 plus 1, and then divide by 3 by 2. Then you will again, we will divide by the differentiation of 3x plus 4, that is 3, and minus it is x squared by 2. So we have the limits now to substitute, and this is going to be in the numerator. 2 2s are 4, so it is 4 by 9 and 3x plus 4 to the power 3 by 2 minus x squared by 2. Now we can put the limits because it's in the simplest form now. So it is 4 by 9, 4 3s are 12 plus 4 16 to the power 3 by 2 minus 4 square, that is 16 by 2, minus the lower limit which is 0. So 4 upon 9 times 0 plus 4, 4 to the power 3 by 2 minus 0 square, that is 0. So we will simplify it. 4 by 9, and here it is 16 square root is 4, 4 cube is 64, minus 16 by 2, 8, and this 4 square roots is 2, 2 cube is 8, 8 4s are 32, so it is 32 over 9. And then we will simplify this. In the fraction form it is coming 152 over 9. Then we have to see the question. They have asked for the exact area, so we can leave our answer like this, or in the mixed fraction form also, and this is going to be 16 8 over 9 square unit. That's the area bounded by the curve, the x-axis, and the line x equals 0 and x equals 4. So that's it. That was the last question. I hope it was of some help. So let's meet again in the next video. Till then, thank you so much.